So in this video, we're going to be taking all that we have learned so far in this section to build a simple coding agent. In this video, we're going to build a simple coding agent. We're going to build our own Claude Code, our own Gemini CLI, a CLI coding agent, our own OpenCode, whichever fan base you belong to. In this video, we're going to start the process of creating a coding agent with LangGraph's deep agent. Now, to begin, first, what are the features that this agent is going to have, this coding agent? What are the features it's going to have? It's going to be able to take a project request. So, to be able to take a project request from the user, so that's one thing. When it takes the project request, it's going to create a folder for each project. For every project request it takes, it's going to build that project inside a separate folder, its own separate folder. Then it is going to plan the execution of the project, then it is going to actually write real Python files. It's going to write real Python files to the project folder. So this is a project we can actually use. This is a project that you can push to GitHub. Yeah, just like Claude Code or Gemini CLI or OpenCode is going to do. So it's going to be able to write real Python files to the project folder. We'll also be adding a reviewer sub-agent. A reviewer sub-agent to help us review our code and apply, and we'll be applying recommended fixes. So any recommended fixes that the reviewer returns, our deep agent is going to apply them. And at the end of the day, we'll be able to deliver a runnable project. And each of the projects that we create is going to include a README file on how to run it. A README file that is going to detail how we're going to be running the project. Isn't this exciting? This is super exciting. We're going to create our own OpenCode. We're going to create our own using LangChain's deep agent. Now, in this very first lesson, we're going to be setting up the coding agent project. We're going to install dependencies. We are also going to create a custom tool that is going to help us name our project so that whenever we say, okay, build me a email validator, it's going to create a project folder for that project and name the project folder with a slug. Name it like this: email validator. Or we tell it to be the product API. It will say product API. So it's going to name our project folders with a reasonable slug based on the type of project that we want to build. Also, because we want to write actual files to our system, you will definitely have an idea of what backend we want to use. We're going to be using the file system backend because that is going to allow us to write files to our system. But we're not going to be using the local shell backend because we don't want to run this project automatically. We don't want to do that. We don't want to install dependencies. We can do all that manually. We don't want anything that executes on its own. So without much ado, let us start building. So the first thing you need to do is to create your project folder. I've created one here. It's called coding agent. You can name it anything you want. This will not affect the project at all. I've created one here called coding project. And we're going to begin by setting up the virtual environment. So I'm going to quickly do that with VS Code. Okay, that is all set up. Next thing we're going to do, first let us go to our command line, which automatically navigates, or rather shows that our virtual environment has been activated. Make sure that you're saying this so that you know you're in your virtual environment. So once we have that in place, we'll then be installing our dependencies. We want to use deep agents. So like I said, to use deep agents, you need to install the deep agents package. Once you install this package, you already have LangChain core, LangGraph. So you don't need to worry about all that. Just install deep agents. So we're going to install this. Then I'm going to be using OpenAI. I'm going to be using OpenAI as I've been using fairly throughout this course. But you can use any provider you want. You can use Anthropic, you can use Gemini, but I'm going to be using OpenAI. So for that, we need to install LangChain OpenAI. So let us install that. Good. We have our dependencies installed. Let us clear our command line and we can get out of this now. Next, let us create a file that is going to hold our code. I'm going to call it simple coding agent.py. Just going to be one file. There is no crazy folder organization for this. Just going to be one file. And inside this file, we're going to be importing our dependencies. First, I'm going to import OS. As we're going to be seeing later, we're going to be creating some default folders. Next, I'm going to import regular expressions, which we're going to be using to dynamically generate our folder names. We're also going to be bringing in some important, or rather the create deep agent helper from deep agent. So we have that in place. Then for our file system, from deep agent backends, we're going to be importing the file system backend. Also, we need to create threads. So we're going to say from LangGraph, not LangChain, LangGraph dot checkpoint dot memory. And if you notice, I didn't install LangGraph separately. I only installed deep agent and I'm already getting LangGraph. So like I said, all that comes with the package. So from here we import memory saver. We import memory saver so that we can create our checkpointer. Then for my model, I'm going to bring in LangChain OpenAI. And from that we import chat OpenAI. And for some type checking, because we're going to be checking the type of messages we get back, you're going to see that later on. I'm going to bring in LangChain core messages and import the base message. If you need to import any other thing or install any other thing along the line, I'll let you know. We're going to do it. You're going to see it here. But for now, this is all we need. The next thing we're going to do is that we're going to be setting up a root folder and writing the logic for creating our dynamic project folders. As I mentioned earlier, for every product request that we get to our coding agent, we're going to dynamically create a project folder. And that will be created from how we describe the project. So for example, if you say you want a product API, it will do this product-API. If you say you want a palindrome checker, palindrome-checker, or power-checker, you just figure out how to create a reasonable folder name out of the description without spaces, just with dashes. We are also going to be doing one thing. All our projects are going to live inside one project folder. We're going to create a default folder called projects. And that is where our coding agent is going to be saving all our projects. That's where it's going to be saving all our projects. So let's go ahead and write the logic that does all that. Back in VS Code, the first thing we're going to do is to generate that default projects folder. We're going to generate it. If it exists, we'll just keep it. But if it doesn't exist, it's going to create that default projects folder. So I'm going to create a new constant here and say projects directory, projects dir. I will say os.path.join. I'll say os.path.directory name. And here we'll say os.path.absolute path for this particular file. And here we'll say projects. So make that directory inside the root of our current file, which is at the root. Our file is at the root. And if it exists, just keep it. Okay, so we have that in place. This is going to, let me put comments here. This is going to set up the directory where all projects will live. So this is going to run that for us. Now, to create folders dynamically, which will be something that will be done during the runtime of the agent. The best way to do that is to create a tool. Create a tool that does that dynamically and creates that folder. And the agent needs to create this folder before writing any files. So that's the first thing it needs to do. Once it gets the request, it needs to create this folder. Then it can then go ahead and start writing files inside this project folder. So we're going to be creating a new tool. Going to call it name project. Let me put a comment here. I'll say project folder naming tool. So call it name project, and it is basically going to take a project name as a string. It's going to take it as a string. The model is going to extract a reasonable project name and is going to pass it to this tool as a string. We're also going to return a string back from this function. And then I'm going to go to the project files which are available to you for this course. I'm going to go to the project files and bring in the doc string for this tool. So I'm just going to put that here and just dump it here. Let's pull this aside for now. So here it says create a project folder with a given name. Call this first before writing any files. The name should be a short, descriptive, lowercase slug using hyphens, e.g. email validator, to-do API, CSV parser. The folder will be created under the projects folder. The argument is a project name, a short, lowercase, hyphenated name for the project. So once we get that input, the first thing we want to do is sanitize it to ensure that we replace things like spaces, underscore. We replace underscores with hyphens because we want to be using hyphens. I'm going to strip any non-alphanumeric characters. So I'm just going to say slug equals project underscore name dot lower. Then I'm going to strip it of all white spaces. Next, let us change any underscores to hyphens. So say regular expressions, substitute. Any underscore you get with an hyphen. That's good. Next, we are going to remove any character that is not alphanumeric. So call regular expression again and substitute. Then we search for any non-alphanumeric characters, replace them with an empty string, and let's pass our slug. So get this. Then I'm just going to strip any trailing hyphens. So say slug dot strip. I'll pass that in. Okay, so sanitization done. If not slug, let's do some value checking here. If not slug, then just return an error. Say error could not create a valid project name. Valid. Then say try a descriptive name like email validator. Try a descriptive name like email validator. So we return that if we don't have our slug, but if we get one, we are going to go to our, or rather we'll define a project path, which will be os.path dot join. We'll give it the projects folder where all our projects are going to live. Give it that, and then we tell it to join it to our slug. So it will be our root projects, which will be created here, then the name that we generated for our actual project. Our root project folder, that's the projects folder, plus the name of our project. Then we create a directory. Create a directory by passing in the project path. And we also say exists. OK equals true. That's good. Finally, we return a message this will be returned back to our deep agent. So we'll say project folder created, the slug / let's just escape there. So we say write all files into this folder using the folder name as prefix. That is, for example, you can call the write file function from deep agent and pass it slug / main.py. Yeah, this is how you write files to that project, and you can simply just pass in your content here. So we're instructing it this way, and you might be surprised how important this is, because the first time I was building this, I was actually giving it the full part. I was telling it, yeah, write to project / slug main.py. I did the same thing here. But that created a bug. It was creating a project folder each time inside the projects folder. It was creating another default projects folder before creating the project folder for the application that we want to build. So it kept doing this. It kept nesting folders. So I had to take this out. No. Just right here. We are already going to be using this projects folder as our root dir, as our root directory for the file system backend. So just write to this part. That's when that bug was fixed. It was quite nasty. So that's our tool done with that. And automatically when we give this tool, let me put some comments here. Automatically when we give this tool requests, let's say build a personal website, it will convert it to a folder name with something like this: personal website. Yeah. If we say, yeah, email and phone validator, can convert it to something like this. You can convert it to email, phone, validator, and on like that. So this is what this function is going to help us do. It's going to take care of the folder naming process and instruct the agent where to write the files to. Next, we're going to start building the agent itself. So we have created our dynamic folder naming system for any of our project requests. Now we're going to go into all this. We're going to be creating the reviewer subagent that is going to be reviewing our code. Then we're going to give it to the main deep agent that is actually going to be doing the coding, and it's going to be writing real Python files. It's going to deliver a runnable project, and also going to include a readme file with instructions on how to run our project. So let's get straight to that. Back here in VS Code, the first thing we're going to do is create our reviewer agent. The first thing we're going to do is create our reviewer sub-agent. Now, why a sub-agent instead of doing self-review? A sub-agent is going to have fresh memory, no memory of the code that is written, and with that, it can provide honest feedback. Also, the reviewer's line-by-line analysis stays in its own context window. The main agent only receives the final verdict, and that keeps the main agent, that's the deep agent's context, clean. So that's why we are opting to create a sub-agent for our code reviewer. To do that, we're going to use the dictionary style to create a code reviewer sub-agent. We're going to say code reviewer equals this dictionary. First, let us give it a name. The name is going to be, unsurprisingly, code reviewer. Code reviewer, that will be the name. The next thing we need to set is the description. And here I'm just going to say reviews Python code for bugs. Yeah, by the way, I didn't mention this is going to be a Python developer. Yeah, this is going to be, we're restricted it to Python just for this demo. You can tell it to be a JavaScript, you can tell it to write JavaScript, you can tell it to write anything, but I just want to stick with Python for now, because Creating a coding agent that supports every type of language is going to take more than just instructions. There are some very edge cases with some programming languages that I wouldn't want to introduce here, and I know that Python goes fine. Python would always work fine. So go with Python, but it can as well be JavaScript just by changing this line to JavaScript, or you can make it open-ended and have it generate anything, and then deal with the edge cases later when you see them. So says reviews Python code for bugs, style issues, and best practices. Then we also say use when code has been written and needs a quality check before delivery. So this is basically another system of using LLM as a judge, similar to what we had with the evaluator optimizer workflow, where one system is writing the drafts and the other one is reviewing them and providing feedback. So yeah, we have our description there. The next thing we're going to add is our system prompt. Now this is going to be a bit elaborate, so I'm just going to bring it in from the project files. Like I said, the project files are available to you in the course resources section. You can see all the GitHub repos there. I'm going to be bringing this from the project file and pasting it in. So copied and pasted. Let us read through this. Yeah, like I told you, it's quite a lot. So it says you're an expert Python code reviewer. You'll be given a task describing which files to review. Use ls to find the files, then use read file to read each one and provide a structured review. Review checklist: correctness, are there logic errors or bugs, edge cases, does the code handle empty inputs, non-values, boundary conditions, style, does it follow Python conventions, that's PEP 8, clear naming, docstrings. Also type-ins, are function signatures properly annotated? Also simplicity, can anything be simplified without losing clarity? We don't want bogus code. Also check that a readme file exists. You know, we said we always want to have a readme file so that we can show the users how to operate this or how to run any code that we generate. For output format, for each file respond with the file name, e.g. filename.py, status, did it pass or needs changes, issues, list each issue with a line reference and suggested fix, so don't just list issues, suggest a fix, and strengths, what the code does well, so that yeah, we can have that reinforcement learning. Also, if all files pass, say all files pass review dash code is ready for delivery. Just say that and we'll know that we're good to go. Keep your review concise and actionable. Do not rewrite the code, just describe the issues. So this agent is not responsible for fixing the issues, just review the code and tell us the issues. The deep agent itself is going to fix them. So once we have all this set up, let's add our tools parameter also. The tools, I'll just set that to an empty list because we're not adding any special tools. We don't have any additional tools. Always declare it so that it can know that it has access to all these file system tools like ls, read file, write file, and the rest. So yeah, we have that set up. We have our review agent. Let's just collapse that so that it doesn't take too much space. We'll come down here. And now we can build our actual deep agent. We can build the deep agent itself. And to begin that, first I'm going to be bringing in the full system prompt. The full system prompt is another elaborate, very elaborate system prompt. So we're going to be bringing that in. So system prompt, copied and pasted. So let us go through this. Yeah. It says you are a senior Python developer. Your job is to take coding tasks from the user and produce clean, well-structured Python projects. Your workflow: number 1, name the project. Use the name project tool with a short descriptive slug, e.g. email-validator, palindrome checker, any of these examples. This creates the project folder. After naming, write all files using the project name as path prefix. So write file my project main.py. This was also where I had that bug too. I was still prepending it with projects, so I had to take it out of this too. So write files to my project main.py, because write file is just going to be using the project directory and going to be rewriting the project folder. If you add it to this, if you say this, it's just going to be creating multiple project folders inside the existing one. So this is how it's meant to be. Then for the planning, use write to dos to break down the task into clear implementation steps. To write code, save all code files using write file. Use descriptive file names, always include .strings and type ints. Then write a readme.md, create a readme file that includes a brief description of what the project does, set up instructions. For example, they need to create a Python virtual environment, they need to activate it, then they need to install requirements, which we'll always put inside the requirements.txt file. But that's if we have requirements for the project. Some Python projects don't have that. Now, how to run the program, for example, Python main.py, so you explain how to run the program and give an example output if applicable. Also, write requirements.txt. If the project uses any third-party packages, if not, if you use standard library, just keep this file. Also, request a review. So delegate a code review to the code reviewer subagent using the task tool. In your description, tell it to use ls and review all files. Also, apply fixes. Read the review feedback carefully. If the reviewer flags issues, use edit file to fix each one. If the review is clean, skip to step 8. And this step 8. Deliver. After all fixes are applied, use ls to confirm the final list of files. Tell the user the project folder name and how to get started. Point them to the readme. And also update your to-do list to mark everything as complete. So that status is attaches to every subtask in its to-do list. Mark them as complete. Guidelines. Write production quality code, not pseudocode or sketches. Each function should do one thing well. Include a brief module level docstring explaining the file's purpose. If the task is complex, split it across multiple files with a clear entry point. Always update your to-do list as you progress. So yeah, give you the full instructions. Even if it knows to do some of them, you still need to tell these guys some of these things. So once we have that in place, we can then start setting up our deep agent. We're going to do the checkpointer. So let us create that. So checkpointer, memory saver. Then we're also going to be creating our model as a chat OpenAI instance. The model is going to be GPT-4o mini. Now I'm using GPT-4o mini because I first used GPT-4o and I started running into rate limit issues, which I'm going to touch on right now. Rate limit issues are going to happen. So you need to check the model you are working with. Our coding agent is going to be calling the API of your provider multiple times, and those calls are going to be quite close. Those calls can be quite close. So you might hit some rate limit issues, especially for people that are using free plans. You might hit some rate limit issues. So first, for demos, you want to pick a model that has a very generous rate limit settings, or you can check their pricing page to see that. Also, another thing is that we'll be setting the max retries parameter. Set that to 3, so that even if we run into a rate limit and it fails, the agent is just going to retry the call. So that also helps. Also, let us set the request timeout to something like 60 seconds so that things don't hang forever. So let us keep it that way. So these are things that you need to set. If you are using a paid plan, you can go for higher rate limits for your particular coding agent, especially if you want to deploy it to production. So that's just one thing that you need to note. Some of the issues I ran into when I was running the coding agent. When I ran a small project, it wasn't so much like a one script project, but when I started running for a particular API to build an entire API, yeah, it started running into some of those issues. So I had to make some modifications. So yeah, we have these two, and now we can create our agent. So agent equals create deep agent. And first we pass in our model equals model. Then we pass in our system prompt, and that will be this guy that we just brought in, then prompt, I'm going to collapse it so we get more room there. Then for tools, we need our name project tool. So let's get that name project, add it to our list of tools. Then sub-agents, we have a code reviewer to add, so let us make sure that we have our code reviewer agent also there. Code reviewer. Good. Next, we need to set up our backend. And like I said, because we want to write files to our file system, our actual file system, we're going to be using the file system backend as we have imported it. We're going to be using the file system backend. The root directory is going to be our project directory. So that's where it's going to be creating our projects. That will be the root directory. Every write operation is going to be going there, and that will be the projects folder that will be created once we run the agent, to be created here in our file system. So we set that, and always remember to set virtual mode to true. I don't know why this is not true by default, but yeah, always set that virtual mode to true so that nobody tries to use prompts to traverse your system by trying to go one step upward the root directory or go to your home directory. Finally, let's get our checkpointer in. Checkpointer equals checkpointer, which for now, because we are running this on our system, we can use memory saver to do that. And yeah, now we have our deep agent. Created. We created a code reviewer sub-agent that will help us review our code. Then we created our main agent. We got a system prompt, got a checkpointer for threaded conversations, because this is going to be running multiple times. Then for the model, we configured the model, tried our best to avoid rate limits. And also, we take all that to create our deep agent. Next, we're going to be writing the logic to run this agent like a CLI tool, the same way you see with Claude Code and OpenCode. That will be next. So we have developed our agent and the necessary sub-agent. Now let us define how we're going to run it. And I've decided that the best way is to run it as a CLI tool, just like every cool coding agent that we've seen out there. So we don't want to be kicked away from the cool table. So I'm going to write a main function. And the first thing we're going to do is introduce our coding agent. Now we can just use a simple print statement, but what's the fun in that? I'm just going to paste this ASCII banner in. Where we get to display our own big announcement, just like all these other coding agents. Like I said, we're trying our best not to get kicked away from the cool table. So we have simple coding agent. This appears first when we run our agent, and then we'll just add some follow-up print statements. You can get this from the project files, so don't worry. Or you can change it and add your own cool version. Probably one better than this. So we're going to say plan, write, review, fix, deliver. Oh yeah, that's some marketing speak right there. Plan, write, review, fix, and deliver. Let's put a delimiter here. We'll do this and say multiply this by 60. Put an empty print statement under it for some spacing. Then add another print statement and say let's use f strings. Okay, I'm already using f strings. Yeah, we'll say projects will be saved to our projects directory. So we'll say projects underscore dir. Put a / there. Just some welcome statements, welcome documentation. So once again, let's add another message here. To the user, we'll say describe a coding task. You can also type quit to exit. Oh no, we're out of that. Quit to exit. Okay, I'll put another empty print statement here. So these are our launch. Yeah, these will help us launch things out and display our cool coding agent. So that's nice. Next, we're going to create a task count variable that just helps us count how many projects have been created. That's basically what it does. So if we have one request, it's going to update and increment this by 1. If we run another request, it's going to update it by 1 and just have that going there. So for our CLI session, let's create a while loop that remains true unless exited. And inside this loop, the first thing we're going to do is collect our user input. We're going to use the Python input function, and here we're going to do all those cool prompts. Yeah, coding prompts. Yeah, so do one of them. You can use anyone you want. Well, yeah, I'm just going to say strip. So anything that comes from this input, just strip empty spaces from it. Then, now if user input dot lower is any of these values, let's say the user says quit, the user says exit, or they just type the letter Q, the common quitting characters. If they put any of that in, we're just going to say goodbye. Going to say goodbye, and we simply break out of the loop. So that's going to end the session. But if we don't get any user input, we're just going to continue. Yeah, we're just going to continue to request. So if they press enter without typing anything, we're just going to continue to prompt them for an input. So we get that in place. Next, we're going to ensure that for each request, for each new task, we are creating a new thread. We're going to create a new thread. And what it's going to do is that it's going to help us separate the projects from each other. It's going to help us separate all the projects from each other, so that one project's context is not bleeding into and confusing another project's context. So any project that we request, the entire thread is going to be new, fresh context, fresh everything, and that's really going to demarcate each project. So first thing we do, we're going to increment our task count. So task count plus equals 1. Then we're going to create a config object. Here we'll set configurable. And inside configurable, we set our thread ID. And that thread ID, we're going to be creating it dynamically with the task count. So I'm just going to say task dash, then here we're going to dynamically put our task count. So that's enough to create a thread ID that demarcates the state for each project request. So I have that in place, and we're just going to have some more print statements here to indicate to our user that the agent is now running. So yep, do this. It should be 60. Then let us print that message that says agent is working. You can give it any cool message. You can say, probably you named your agent Jon Snow. You can say Jon Snow is working, or winter is coming. Yeah, any cool thing that you want it to say. But just make sure that you're telling the user that something is going on. So yeah, here we put another delimiter and finish off with an empty print statement to just add some white space. So yeah, this is good, this looks good. Now let us run the agent itself. Now we can come over here and just say agent.invoke and run it with our input, but that is not going to provide a good user experience that coding agents give when they are actually working. If we do invoke, we're just going to see the request going, then everything is just going to pause. We're just going to stand there or sit there waiting until something is done. It's not going to give us any feedback. So the best way to run this type of agent is to stream its output. We need to stream its output. So with that, you can see how the process is going on, all the planning, all the tool calls and everything. You can see how it's going on. So here we are going to be streaming. And to do that, we're going to say for step in agent.stream. Step in agent.stream. We're going to pass in our messages. We definitely need to pass in our messages state variable. We're going to have just one message with the role of user, and the content is going to be our request. Content is going to be our request, which is basically our user input. So we have that in place. Also, we need to pass our configuration. You can just pass it as config because it uses the same name as the parameter itself. So say config. Then let us set stream mode to update. So that we get the new things that are going on. Not values, updates. So we get the updates. And as we get the updates, we're going to say for node name and update. Then we loop over all the step items. Say for node name update in step.items. Then inside here we'll say if updates and let's get the messages if they exist. So update.get say messages. Update.get messages. And once we get the messages, we'll say for message in, we check if our message, that if our messages, if it is an instance of a list. So if it's a list, else if it's just one message, we're just going to put it into a list of our own. So we're going to say messages and put it in a list. And inside here, we can say if it's instance. So we'll first check if any message that we are passing, if it's an instance of base message, because not everything that is coming out of updates is a message. That's even one error I got when I was trying to do this. I was just trying to print the message, and some of them just bounced. Some objects came around and they are not of the type base message. So I had to do that type checking before printing things out. So this should be good enough. This is good enough. Down here we can just put another empty print statement, just close things out. So yeah, we are streaming our output. Awesome. Now to finish things off, let us go down here and say if name equals main, call our main function. Pretty cool. Pretty cool. So let's save this. And now we have everything to get our agent working. If we pull up our command line, let me pull up this too. I'd love to pull this up very well. Yeah. But I want you to see how the projects folder is created. We pull up our command line and run our application by saying Python simple coding agent. Hit enter. Open no errors. Oh yeah, I think there's going to be an error. Let us, oh yeah, definitely. I didn't put my OpenAI API key. I just remember that there's going to be an error for sure. So let me just copy this environment variable. And now we'll say export OpenAI API key. And I'm going to put my API key here. So that's one thing you need to do. You need to put your provider's API key before you can run this. So now that I have my API key in place, we can run this program again. Hit enter. And voila. Yep. There you have it. Simple coding agent. Plan, write, review, fix, deliver. How awesome is that? And tells you project will be saved to this location and describe a coding task, type quit to exit. And it gives us that cool prompt, that cool coding prompt. Awesome. The next thing we're going to do is that we're going to be testing this out with two projects, a simple one and one that is slightly more complex. And we'll get to see what it does for us. By the way, as you can see here, we now have the projects folder. We have the default projects folder where all our coding projects are going to live. So we have completed our coding agent. We've run it and everything looks good so far. But that doesn't mean that we might still not have errors. There might be errors in the deep agent itself. There might be errors in how we are running it. There might be errors in the code reviewer, but hopefully we don't have any errors. So the first thing we're going to do is try it out with a simple project. Let's give it a simple project to run. I'm going to tell it to create a Python application that just tells me the time zone and the current time. Something very, very simple. So here, let us say, create a Python application that can tell the time zone and current time. Create a Python application that can tell the time zone and current time. Let it enter. And see, it says agent is working, and the agent is actually working. And as you can see, it's doing its thing. 2 messages, calling the right to-dos. You see the right to-dos is writing out the plans. It's calling another tool to write a file called main.py, as you can see here. I think he called it time zone clock. Interesting. So yeah, you see messages coming back. It's telling us it's writing a new file, requirements.txt. Sometimes it kind of pauses on one file, maybe it needs to write a lot. Then it's writing our readme. The review is going on. The subagent is taking over here, doing the review. The review comes back. You see that it needs changes. So the deep agent is going to undo those changes. Oh, I think it has passed here. So it has passed here. So we should be done anytime from now. Looks like this have been handled. He pointed out some stuff in different lines. And now, okay, yeah, this is for each file. Okay, it's passing files and saying files that need changes. So it's going to be correcting the files that need changes and just going to be ignoring the ones that pass. So it's doing that correction now. And you see, we are getting more results back from the correction. Successfully replaced some items, fixing some errors, fixing errors. You see, this is just beautiful. Beautiful. It's even showing us the old and the new parts of the file. And now it's done. Now it's done. Now it's done. Let's see. See, I've completed the main application for you, but I'm facing the issue with editing. Okay. Say, despite the challenges with the edit, the application is functional. Here are the final files of time zone clock. Main.py contains the logic for the time zone handling. Requirements.txt, it lists the dependency that we need to install, then a readme file. So, and it also shows us how to run the application. It was mentioning some difficulties editing the main.py file based on the review feedback, because it seems my attempts find the specified lines have been unsuccessful. Interesting. So, giving you feedback. And now if we look at the project is here inside time zone clock. Is there inside time zone clock? We can see the main.py file. We open it. You can see it here. You can see the file here. And we can also see the readme. But we're going to be checking all that later when we're actually running the application. So we've created one application now. We've created one application. Quite simple, straightforward. Let's push it further. Let's push it a little further. And I'm going to try my best to still make a lot of things in real time, because it's fun and educative to see how this thing is running. But if it gets way too long, like unreasonably long, definitely I'm going to cut out all the parts that is not necessary. But this is still going to be the single run. It's still going to be the single run. If there are errors in between, then we're going to address those also. So let us give it a more complex task. Let's say create a fast API with CRUD endpoints for a product entity. Yeah, create a fast API with CRUD endpoints. Sorry, I started typing funny characters. Sorry, I mistyped some things there. Let me just exit this. We're going to come back. We're going to rerun this. Yeah, just rerun this. Sorry about that. My fingers just pressed a couple of characters and I couldn't go back. So we're going to write this again. Say create a fast API with CRUD endpoints for a product entity. Yeah, create a fast API with CRUD endpoints for a product entity. This is more complex than just creating something that will just tell us the time and show us the time zone. So let's see this. Let's see it working. And you can check out the outputs. For example, if you look at write to dos, you see it has the plan, set up the project structure, create a product model using Pydantic, implement CRUD operations. You see, you can check out all those stuffs. They're pretty cool. So yeah, it's running. I don't know whether these are the instructions. Okay, it's already writing the files. It's already writing the files. So it's writing, it's checking. I don't know whether the review has kicked in. Oh yeah, interesting. This was quite fast. You can now access the API endpoints to manage your products. If you have any further tasks or modification, let me know. Funny enough, this was faster than the time zone stuff. Writing a whole API was faster than the time zone stuff. Interesting. So if we look at the projects folder, we see the two projects that we created. The time zone clock, which was created from our first request for creating a Python script that shows us the time zone and the current time, and also the fast API product API. You see how he's naming it, giving us the files. It's naming it according to our request, which is just pretty cool. So now the next thing I'm going to do, I'm going to be opening this project. I'm already in a virtual environment for this particular coding agent. So what I'm going to do is that I'm going to go out of this project and open these projects in their own VS Code instance, and we get to run them. So let's do that. First with the time zone application. So I have opened time zone clock. Let's see if I can. Yeah, time zone clock. I've opened time zone clock, and we're going to be testing this out. First, to run it, we check the README file. As you can see, setup instructions. It also tells us what the application does, a simple Python application to display the current time for a given time zone. Then for setup instructions, we create a virtual environment, use the command on Windows, then we install our dependencies, and to run it, we simply just run python main.py. An example output is this. It says enter the time zone, e.g. Oh, interesting. And it gives us the current time in that time zone. So that's cool. Let us run this according to the instructions. So first it tells us to create a virtual environment. Let us do that. Let's create a virtual environment. This is asking me for dependencies to install. Yeah, install. Yeah, you can do that. So this is just going to set up the virtual environment and also just install the packages. So I'm doing those two in one go. That's nice. Now if we look at the code, yeah, this dependency error is clear, so we don't have any squiggly line under here. You can also check out the code. As you can see, it's giving the functions very proper docstring, and we have also instructed it to write production level code. So let us test this out. Let's go to our command line, make sure that we're in the virtual environment for this project, the time clock, and we'll say Python. Let me clear this once again. Then we'll say Python main.py. Python main.py. So on this, and it tells us to enter the time zone. Let's do Asia Tokyo. Asia Tokyo. Yeah, Asia Tokyo. So tell us the time in Tokyo. And it says the current time in Asia Tokyo is today's date, which is 27th of February 2026, and is around 9 p.m. Interesting. Currently where I am, which is GMT +1, it is currently 1 p.m. 1 is 1:38 here, but it's 9:38 in Tokyo. Interesting. They are like 8 hours ahead of us. So pretty cool. We just gave a coding agent instructions and it built out an entire application for us, and it's working. It's working. Now, I know some of you are already rolling your eyes and like, yeah, this is simple. So go to the fast API stuff. Let us see how that works. Yeah, let's do that. Let's do that. Let us switch to the fast API project and let us run it. So now we are in the fast API product API. As you can see, fast API product API. We have some requirements, which is fast API and UVCon. Then we have our README, which is going to tell us what to do, and our main.py file where all our code lives. You see fast API, you see Pydantic, you see typing. Fast API and Pydantic. No, fast API is the only dependency here that is installed. I think if we go down here, we can see where okay, I think we'll just use UVCon to run it from the command line, not from a main call on the file. So yeah, we have Pydantic model validation going on here. The products are stored in memory. They're stored in memory because we didn't tell it to be that robust and start connecting it to databases and stuff. We could have told it to use a SQLite database, and I'm sure it will definitely do that. We can also tell it to use Postgres, and it will definitely ask us for a connection string and all that, and even probably run migrations to set up the table. So yeah, but this is simple enough. Let us run this and see what we get. Let's go back to the README. It says we should create a Python virtual environment. Good. Then we should install the dependencies from requirements.txt. Nice. Then this is the command that we're going to use to run it. Uvicon main app reload. There we can copy that. Just copy. Okay, good. So with that in place, we also get the endpoints. You create products, read all products, get products, and all that. So let's test this. We need to create a virtual environment, so let's do that. Yeah, it's also asking us if we want to install. Yeah, I want to install from this. So we do that in a go. Virtual environment creation, dependencies installation, everything should be done in a few seconds from now. So we do that and we get our API. Let's pull it up. Make sure you're in the virtual environment. Very, very important. Then I'm going to paste in this uvicon command that we're going to use to run this app. Hit enter. And it's up. It's up. It's coming up. Wonderful, wonderful. So let's do something. Even though, like I said, I'm not. Yeah, we can test this. Let's go to our browser. Let's go here. Obviously, we're going to see all this. But let's go to the docs. Yeah, let's go to docs. So we go to docs. And here we can create a product. And click this. And I'm going to click on try it out. Yeah, let's click try it out. So the request body needs to be in JSON. Let's say we want to add a product with an ID of 1. The product name will be, let's say, MacBook Pro M4. The price is, let's say $4,000. I don't know what the current price is, but let's say $4,000. And let's say the all-powerful new full specs MacBook M4 Pro. Yeah, let's do that and let us execute. Let's execute and it's done. That was fast. Yeah, it's basically saving to memory, so that was fast. We get a 200 response back. This is the call request that is generated and it gave us a successful response. So that's good. Let's add another product. Let's say we had what else? Let's say an iPhone. Yeah, iPhone. We're going on Apple this time. iPhone 7 or 17, sorry. iPhone 17. This has an ID of 2. Let's say it's $2,000 for the one we're going for. And we'll say iPhone Max. Yeah, whatever. iPhone 7 Max. iPhone 17. Why do I keep calling 7? That's like 50 years ago. So iPhone 17 Max. Let's execute that. Definitely going to get another success. So that's good. Now we have added 2 products. Let us try and read products. Just going to click try it out. We don't need any parameters, so I'm just going to click try it out. Execute. And we should get 2 products back. Yeah, get 2 products back. Our MacBook M4 and our iPhone 17. Awesome. Our coding agent just built this API. We didn't write a single line of code. Our coding agent did this, and that is just mind-blowing.